Hello, everyone. I am Mike Jones, the Education Manager with the Oracle Applications and Technologies Users Group. I'm very excited to welcome everyone to today's e-learning session titled The Layers of IT Infrastructure, Can and How Do You Support Your EOL Systems? Before we dive in and get started, I'd like to briefly introduce everyone to the OATUG. In case you're new to our programming, OATUG is a community of Oracle users, and we provide education, networking, and support to all our members. We have an exciting event coming up in August called Ascend 2021 in Hollywood, Florida, which we're hosting in partnership with another user group, OATUG. It'll have tons of great education with in-person and virtual attendance options. We have an early bird deadline for that that's going to end tomorrow, so I'll place that link in the chat area if you do want to attend. It's at a beautiful property in Florida. Lastly, just a quick reminder for today's session, you will be on mute throughout the presentation. However, you are welcome to send questions at any time in the question box in your control panel, and we will get to those at the end of the presentation. We are recording the session. The recording, as well as the slide deck, will be available later this week to OATUG members in the knowledge base. You'll see that link in the chat area now. Next, I'd like to turn it over to one of today's presenters. Her name is Sandy, and she's from Stromasys. Thank you so much for presenting. Take it away, Sandy.
Oh, no problem. I have myself here, Sandy Levitt, and Caleb here. And what I'm going to do is we have the webcams on, but we're going to turn them off to sort of save on bandwidth as we're doing the presentation. We just wanted everybody to see what we look like and just so you can put a name to a face. So I'm going to shut my webcam off right now, and then I'm going to get started. So basically, my name's Sandy Levitt, and I'm with Stromasys. And basically, before I was with Stromasys, I spent over 27 years at what was the DEC Compact HP. And most of what I did, I was a pre-sales engineer at one point for the Southeast Government District, but I also, for most of my career, I supported both their Ultrix and their 264 Unix operating system. That ran on the Alpha, and then I came over to Stromasys, and I've been a senior pre-sales engineer now for almost 7 years, actually. So it's 6 years, I'm coming up to 7 years. And basically where my focus is I'm focused on our channel partners and helping them get up to speed and, understanding our products, as well as our alliances, many alliances with all the big vendors, such as the cloud vendors and, VMware, Nutanix, or whatever else alliances, we have out there. And so I work together, and I also work with cloud. I essentially do a lot of work as far as what we put out there in the cloud marketplaces. So that's my background, and I'm going to turn it over to Caleb, who's going to discuss his background.
Hello everyone. Thanks for tuning in. My name is Caleb Ruth, and I'm a senior account manager with Parsec Group. Parsec Group is a consulting firm. We've been around since 1986. So similar to Sandy's background with Digital Equipment Corporation, we have a lot of engineers here from DEC, also Oracle and IBM. But we specialize in operating systems, specifically OpenVMS, several Unix distributions, as well as the Linux operating system and all the distributions and versions of that. We provide support, training, software development, managed services, consulting services for these operating systems. And I work with our channel partners, direct end users, and within a variety of industries.
So basically what we're going to be talking today is about what the different layers of infrastructure is and the drain, the overall drain there. And then we're going to go deep dive into the layers, and we're going to focus on two areas, the legacy hardware, and then we're going to focus on the operating system and, the different areas of, different things that can concern you with legacy operating systems. And then we're going to talk about, how do you move forward with these together, and then we're going to go towards the question and answers at the end. So basically, when you talk about layers of infrastructure, you have three different layers. You have the application software, and usually this application software can either be from a third party, it can be an Oracle ERP app, or it can be something homegrown. And when these applications, once they're written, they're out there, they're doing their job. A lot of them are customized. A lot of the people who wrote them are no longer even around, so you don't have the source code to these applications. And they're running on these older operating systems, these legacy operating systems. I like to call them the Unixes from the 90s, or the proprietary operating systems that are out there, such as OpenVMS, True64, Solaris, HPUX, and so on. And then we're talking about the hardware layer. And the hardware layer is the layer of which these operating systems are running on certain hardware architectures, such as SPARC, Power, if you were talking about IBM, or you're talking about Alpha, VAX, RISC, PA-RISC, and so on. So what this shows you is that the application, and I'll go about this a little bit later on, more about the detail of this, but when you're talking about your infrastructure, one of the major drains you're going to have, especially as you're dealing with, older infrastructure, is you're going to have a threat of, you could have a threat of unplanned downtime. You're having increased costs, especially in the legacy space, of the cost of maintaining that legacy systems, whether it be in the data center, or whether it be, how to, upkeeping that older application or that operating system, and and Caleb's going to discuss more on the operating side of things. And then, of course, how do you take advantage of newer technologies, when you're running this older application? And, how do you remain competitive in your market? And of course, from the operating system side, some of the most important things is security, and how do you keep everything secure? Security has become more and more important in today's world. You're always hearing about large businesses and ransomware and everything. So how do you just maintain that security on your legacy systems? So I'm going to go back and I'm going to talk more, as we talk about this, this hardware, and everything. When you talk about these applications that are really, really stable and unique to yourselves, and they're running on these operating systems, which have hit end of life, and for the most part, they're pretty stable. But then they're running on this hardware that's very, very old, and hardware is not going to last forever. So the question is not if the hardware is going to fail, but when is this hardware going to fail? And what are you going to do when this hardware fails? I've talked to people who, have 20 machines and they're down to the last 2. And so the challenge here is, what do you do? And I'm going to talk more about what those challenges are a little bit further on. So, the other part is the growing, the gap in support, where, get the spare parts and getting those spare parts, and the growing cost. I mean, the maintenance on legacy and, space, when you're talking about the hardware side of things, the maintenance of it, the space, the power and cooling, data center space has gotten really, really expensive. The hardware is becoming unstable. I know that when I was dealing with the calls coming in when I was still at HP, a lot of times when systems were going down, it was due to storage issues or other hardware issues more so than operating system. And then, of course, there's diminishing legacy skill sets on, the hardware side, who can fix this box, who's still available out there to do that. And there's also diminishing legacy skills from the software side of things, which Caleb will talk about a little bit later as well. So the risk there, hardware failure can count for 31% of unplanned downtime, and this was a Forrester report, and I can also attest to this. Like I said previously, when I was getting support calls, a lot of the errors that people were calling in about, we'd always say, oh, we got to turn that over to the field service team. So, as hardware gets older and older, there's more unplanned downtime. And when you have downtime, it's going to cost you, it's a large risk, and it's going to cost a lot of money when your systems go down, because they're running your, whatever they're running, whether they're running your payroll, they're running your manufacturing floor, or whatever they're running, these older legacy systems, have an increased risk of failure and downtime. So what are you going to do with this legacy hardware that, you're dealing with here? And as we have shown previously, it can be it is expensive to almost leave it as is and risky, because if you do have that downtime, it's going to cost you a lot of money. Then we can talk about spare parts. I like to say that we compete heavily with eBay, but how do you know what kind of spare parts you're getting? How do you know even that's also risky? How do you know those spare parts are good? Do you have to do extensive testing of them? Buying spare machines from eBay. So sometimes you can buy all that. You can buy extra old legacy systems out there, but they're getting farther and farther and fewer between. So a lot of people are going through the migration. They're saying, okay, we're going to have to rewrite this app, or we're going to have to use a new application for our business. And they're going through that hard work. And that's taking, that takes time and money, and it's not very, very secure. So, you can continue to do that work, and we do recommend that you continue to do that. But one of the things you can do while you're waiting to rewrite the code, if you chose to do so, or even if you don't choose and you want to continue to run with this application in your business, is you can do lift and shift with emulation. It's very cost effective, it's very secure, and an easy way to keep your legacy systems up and running, especially the legacy application that's running your business. So when we talk about lift and shift application, what are we talking about? Well, we're talking about taking these legacy hardware platforms, and I have some of them listed here. And on top of that, they're running their legacy operating system. For example, it's on SPARC, running, Solaris, and we could be running an Oracle database, and we could Oracle ERP system on top of that, or a homegrown application, or whatever you're running. So what we're talking about in this case with the emulation is replacing that hardware into any modern x86 or cloud with a Linux operating system on top of the modern Linux, and the Karen solution, which is the emulation layer. And then everything you're talking about from the top, when you're talking about the legacy operating system, you're talking about the database, you're talking about the application, there's no changes. It's just a dump and restore. It's a lift and shift over so that everything runs exactly the way it ran on the old hardware. We're just doing a hardware type of emulation here. So that's what we're talking about when we're talking about emulation. And this, like I said, can be as an intermittent solution while you're rewriting that application or updating that database and that operating system, or it can be long-term, especially some people need things for archival purposes. So, you still need that data out there. For example, some people have old college records that have to go back many, many years, and they were first initially created on these older legacy systems, and it's not that someone needs a transcript every day that graduated in the 1980s or 1990s or whatever, but once in a while they do. So that's another way where you probably would want to, keep these things up and running and not necessarily do the rewriting. So now I'm going to bring it over to operating systems, and I'm going to turn this over to Caleb.
Yeah, thank you, Sandy. So the operating systems that we're going to discuss today as it relates to the emulation software provided by Stromasys, related to the VAX and the Alpha, the SPARC, the HP 3000, or the HP 9000, is we're going to talk about VMS or OpenVMS, that operating system that runs on VAX or Alpha. We'll talk about this conversation also pertains to True64 Unix running on Alpha, and Solaris running on SPARC, or SunOS is another operating system that's similar. MPE running on HP 3000, and HP UX or HP Unix running on HP 9000 or a PA-RISC architecture. So a lot of companies running these operating systems, they've relied upon them for years, in a lot of cases even decades. So as people retire and new folks take over, they may look at these systems and potentially see them as being problematic for a handful of reasons. So we'll discuss a few of these perceived challenges related to diminishing technical expertise and supportability of these operating systems, along with security and patches or lack thereof. We'll also touch on some easy to implement solutions to some of these challenges, which would be version locking and ring fencing. So diminishing technical expertise, the number one most unanimous thing that we hear when working with organizations is we used to have a guy for that, right? And that's a very popular quote that we hear all the time. We used to have someone for that, but for whatever reason, that person that was managing the system, their system administrator has since retired, they were outsourced, whatever the case, they're no longer with the company, and none of the current staff have the very specific expertise to efficiently troubleshoot and resolve issues when they arise. These systems have been running for decades, and they haven't had any issues other than hardware, which Stromasys solves. But they need someone there. They don't have them. But just like redundancy in your IT in your disaster recovery planning for your IT systems, you should also have redundancy in your staff. So in the event of an emergency, you aren't depending purely on one guy, or possibly worse, as the Dilbert cartoon, have to call Carl and ask if he can come back after you laid him off to help out. So having a well-trained staff is very important. Supportability. So there's often a major misconception around these older operating system versions, being that nobody still supports these systems. But it's important to properly define what support means and what to look for from a support provider when seeking outside support. Organizations often approach selecting a support provider by choosing whoever or whichever group can provide them with patches and fixes, which traditionally is the vendor or the OEM of the operating system. But when it comes to these older end-of-life or EOL versions, the vendor likely no longer provides patches, and in some cases aren't much help or readily available to help open a ticket, a support ticket for you when you have an issue. So when you try to approach finding a support provider, being that you're looking for OEM patches and fixes, you'll have a hard time because they often won't exist for these much older versions. So the key to sourcing support or a support provider for these systems is to take a different approach. You want to focus on finding a support provider who specializes in expert troubleshooting, and that's the big keyword, is expert troubleshooting for your specific operating system and version. A group that can roll open source package updates to help you address critical vulnerabilities when and if possible, and can help you implement workaround strategies specific for your version and your needs, knowing that the OEM no longer provides patches and likely won't be of much help if you're in a crisis. Another quality to look for in a support provider for end-of-life systems are ones that provide or offer remote system administration services. Remote system administration is a service where they will perform all the duties a diligent system administrator would perform, except they'll do it remotely. And you won't have to deal with the headaches of performance reviews and expensive salaries and their benefits. So the takeaway here for how to address diminishing technical expertise and supportability is to first enable your team to learn your specific operating system version. There are 5-day courses online led by live instructors they can sign up for, and they'll be far more equipped to be a resource for you afterward. Also, take a different approach when selecting your support provider. When it comes to these end-of-life systems, you want your systems under support with a provider who has readily available technicians that will answer when you call the first time and who can create a support ticket, jump on a video conference with you, and talk you through resolution. Better yet, find a support provider who will do this and educate along the way, so they're providing training with every support ticket they help you resolve. Security and patches. This is always the big one when it comes to end-of-life or end-of-support versions, right? And it's kind of in the name, right? It's no longer supported by the OEM. That means there's no patches, there's no updates being created. And IT managers often get stuck into thinking that they constantly need to patch an already stable system. Operating system software is not the same as hardware. It doesn't age the same way. oftentimes it just becomes more reliable, right? The bugs get worked out over time. So what they really need, as discussed previously, is expert troubleshooting and strategies to ensure availability, security, and reliability of the system. Not everyone agrees on what constitutes a patch. There are various parts of the operating system landscape to update, and not all of them go into mainstream patches. So for the purpose of this overview today, we'll break down the difference between an operating system patch affecting a user space program, the kernel, or a bit of hardware. We categorize these in 4 main areas. Stability patches, these usually are fixes for issues discovered by users of their own lab techs, i.e. patch addressing a system crash under specific conditions, or a patch fixing a severe performance issue that only happens when the system is under load. Security patches, these are by far the most critical patches to apply when put under any type of regulatory framework. Why? Reason being is because you could fail an audit otherwise, right? So this is usually a bigger deal than an instability bug that you may or may not be running into. Kernel patches, just consider the fact that most operating systems experience kernel patches in the first year or 2 of their lifespan. After that, the bugs are typically found via normal usage and the everyday use of the OS for intended purposes. And then finally, firmware updates. Keep in mind that vendors tend to stop upgrading firmware after 1 to 3 years from the release date. This is because they generally feel pretty confident and stable about the code as their bug reports begin to slow and die off. A few points on this. Only the vendor can provide firmware updates and kernel patches. If a system is no longer supported by the vendor, then these types of patches and fixes are not going to be able to be found, right? If they're no longer providing them, no one else can provide them except for the vendor. Now, most exploits and issues are found when an OS is in its mainstream lifespan. Few issues pop up after the OS goes end of life. There are key fixes and internally sourced non-vendor patches for critical vulnerabilities, such as like secure shell, inetd, SendMail, etc. But so long as a code fix is freely available, there are potentially fixes for those critical vulnerabilities. And in situations when there are critical CVEs which we cannot address from any angle, there could be workarounds or strategies you can take, which we'll discuss a little later. So it's important to be aware of the types of patches because in most situations, there could be thousands of updates available on your version, right? If you just took over as an IT manager, IT director, and you're looking at some of this legacy equipment, and you got these legacy systems, you may, say, wow, there are, thousands of updates that need to be done. We have to migrate away from this system. But a lot of people often think that there is only one avenue when it comes to fixing a bug or an update, which is if there's a bug of any kind found or any update available, it must be patched by the vendor. And of course, the vendor no longer provides that fix. So if there aren't any patches available because the vendor no longer creates them, you must upgrade or replace the system. But this isn't necessarily always the case. And the flowchart here summarizes an alternative way of thinking. So if you can see from the upper left, there's a bug found. You should first ask yourself, do I need this service? So if a particular service of the OS has a vulnerability, are you using it? If the answer is no, simply disable the service and declare victory. If the answer is yes, well, ask yourself, does the vendor currently support this version? Do they have a patch for it? If the answer is yes, go ahead and apply the patch, declare victory. For many running older operating systems, the answer is no. And you should ask yourself, can an open source update be written? Is this a proprietary kernel or a firmware update? Or is there open source code available that you can roll a patch like for SSH, for example? You can go ahead and roll that open source non-vendor patch, apply the patch, and declare victory. But if the answer is no, an open source patch cannot be rolled, well, then you need to implement a workaround and ultimately will lead you to victory. So one of the workaround strategies that many organizations take is version locking. Version locking or implementing a version locking strategy is a popular workaround many organizations can take in order to secure an environment for something that has an unpatchable problem, which must be addressed. So how do you create a secure environment for something that's got an unpatchable problem? It is possible. The key fact that we're attempting to capitalize on is that most audit standards don't tell you exactly how you must solve security problems. They merely require that you have a policy that offers a solution and that it protects the company in the real world. Oftentimes, this can easily be accomplished through a version locking strategy rather than an expensive migration, upgrade, or outright replacement. Now, this isn't to suggest that version locking is a superior solution, but for many who are running older versions, staying on the latest version, that ship may have sailed quite some time ago because the application is written to run on a specific version of an operating system, which is basically proprietary to a specific hardware architecture. So some folks will only consider the costs, or when it comes to the costs for upgrading software, they're not always clear. Some folks will only consider the actual cost of the latest software, but they may fail to consider the costs associated to the new hardware, new fully licensed operating system, new storage costs, and the potentially enormous cost of migrating the data and the metadata, like the database triggers and functions, for example, to the new system. Version locking avoids all that cost and leaves you with a system that's already familiar and paid for. So let's review a scenario where version locking made a lot of sense to do and was an ideal solution, which would be company XYZ. This is a real world example from a previous company that we worked with, but basically a little bit on the background. They had an older system which ran critical parts of their ERP system or enterprise resource planning system. The operating system had been end of life for 10 years, and the application is now 6 versions behind, and the application vendor will only support the application on an expensive consulting arrangement because of its age. They haven't upgraded mainly because the new version would cost them significantly. There was also the cost of upgrading the servers and licensing the new operating system, while their current version had been working great for their business needs for years. So they wouldn't normally care to upgrade, but in this situation, they were purchased by a Fortune 500 corporation, and so now they have Sarbanes-Oxley requirements to fulfill, which means that the mother company's security policies were now incumbent upon them. To make things worse, the company was not prepared to make the financial outlay required to migrate to a newer ERP system or upgrade their old one. They also didn't have time or the resources to do it for the next audit, which was coming up within a few months. So what options do they have? Version locking is a great solution for this type of situation. So what is the solution and the outcome? Well, knowing that the OS has several vulnerabilities that don't relate to their application directly, the company pursued a version locking strategy. They employed a firewall to mitigate access to the vulnerable OS, and then they set up a jump server to access their application and don't allow any connections directly to the system other than from key authenticated admin users. Also, the application itself had an older known vulnerability, so they disabled that portion of the software so that it can no longer be used because they weren't doing so anyway. And disabling specific functions that you're not using, that's just standard security practice. You should never have anything open that is not actually in use. So what was the end result? When audit time rolled around, each item which would have violated the security policy had been addressed or mitigated, and the auditors find that the system now meets or exceeds the corporate policy. Thus, the company saves 7 figures and a lot of hassle, including a possibly failed audit. This is the kind of situation where version locking succeeds brilliantly. And then inside of a version locking strategy, and where things can get a bit more technical, is implementing ring fencing. Ring fencing is a strategy within version locking that isolates systems, specific areas of a system or groups of systems. A few components commonly found within a ring fencing strategy would be firewalls for isolation, intrusion detection systems, proxy server techniques, bastion servers, virtualized containers, and then of course crafting policy upgrades and changes within your documentation.
So now we're going to talk about, together, this how we work. You can, with Stromasys is able to address the hardware issues that you're dealing with your legacy systems, and then of course Parsec is able to then address the operating system and the things that Caleb talked about. So with Stromasys, which does the hardware emulator, just to give you an idea of what a portfolio is, we have Karen VAX, which can emulate the older VAX VMS systems. We have Karen AXP, which can emulate, do that hardware emulation of the alphas, which ran through 64 in OpenVMS. We have Karen PAR, which does older PA-RISC systems for like the HP 3000s and also the PA-RISC HP 9000s, so that you can do hardware emulation on those. And then what has become probably our most popular product is Karen SSP, and this is for all the different SPARC architectures, and now later the Oracle SPARC. We're talking Sun 4M, Sun 4U, Sun 4V systems, and we're able to emulate for all the different SPARC architectures. And of course, we still have customers out there that run PDPs. We still sell Karen PDP. So a little bit more about Stromasys that I'd like to tell you about is that we're the tech leader, in legacy platform, and we had our first launch all the way 20 years ago. We have thousands upon thousands of licenses across the world. Our support is 24/7, follow the sun. We have offices and of course partners everywhere, all over the globe. So we're an international company, and we've been around for a while. Like I said, we had our first launch in 2001. So we're, been around, we know what we're doing. We're, in emulation. And of course, like I said, we have emulators for most widely used, which is VAX Alpha, SPARC, the PA-RISC, and PDP. I know a lot of times people will ask us, do we do IBM PA-RISC? And unfortunately, that's something that's not part of our portfolio, because we would need IBM to give us permission to do so, and they have not. We have worked with people in IBM, and we're just not at that point, but we're always looking to see what is needed and where emulators are needed, and stay tuned, there might be something in the future as well. And then Caleb's going to discuss about Parsec.
Yep. So just to recap, we specifically specialize in supporting operating systems. So we are just that OS layer. So after Stromasys solves your hardware headaches, your OS is rock solid. It just needs to be supported. Maybe you need a system administrator for that. We provide that as a service. And we also provide training. So for OpenVMS, True64 Unix, HP UX, IRIX, AIX, Oracle Solaris, or SunOS, and Linux, we support all versions. And again, redefining what support means, being that we can provide expert troubleshooting and workaround strategies for when there's an unpatchable problem that must be addressed. We provide 24/7 OS telephone support, which is like a help desk, right? Except it's a little bit above and beyond what a help desk would provide or what an OEM would provide from a support perspective. We provide managed services, being remote system administration, remote system monitoring, plethora of consulting services. We've written device drivers for NASA and a handful of other software development projects, migration services. We can help you with moving to Stromasys solution, whether it be on-prem, private cloud, or public, with a major provider. And in the custom training that we do, 5-day on-site courses or online courses, or here at our headquarters in Colorado. And then everybody will be able to have access to this. So this is more just a visual aid. As a reference, you can see which operating systems we support, the commonly found hardware that it's running on, which Stromasys has solutions for, and the versions that we support of these different operating systems.
So here's the part where we're going to get to the questions, and our email is going to be on the screen. So if you have any questions that you want to ask us privately, feel free to reach out to us, and we'd be more than happy to help you in any way, or dig deeper into any of these topics that you would like. And we're going to open it up for questions at this point.
All right, well, thank you. Yes, I'd like to thank you for doing a great presentation. Just a reminder for everyone, if you have questions, please type in the question box of the control panel. As a reminder, we will be posting this recording and slide deck in the knowledge base. While I give everyone a moment to send in their questions, again, I posted a link to our upcoming event, Ascend 2021. Right, we do have a couple of questions, so we'll get started with those. The first one, again, I'm going to put them into the chat area and read them off. Can I emulate to the cloud, and then which clouds?
Okay, so yes, you can go to the clouds, which will help you, of course, in people who are exiting data centers, and it's all the major cloud providers, anywhere from AWS to Azure, Google, IBM, Oracle, and even, for example, VMware on the cloud, or VMware in-prem, or even on-premise, hyperconverged such as Nutanix, but definitely, and also private clouds. We can do private clouds, and we generally can emulate, as long as it's an x86 platform, we can emulate to it.
Okay, perfect. Next question. How quickly can you help me figure out what to patch?
Yeah, so that's actually a pretty quick thing to figure out. It's just a security analysis. We just go through, it takes a couple of hours, and then we can kind of give you a health check update to relay to you, document for you, or help you fix up any critical vulnerabilities, loose ends, or address things that might need a workaround. Couple hours.
Okay, perfect. This might be a kind of follow-up to the first question. How does emulation impact performance?
Basically, there is going to be some performance in emulation, of course, because there is overhead to it. So it does impact performance. Now, it depends. I mean, if you're talking some of these older legacy systems that have been around since the 1990s, you're probably going to see some increased performance. But, as you're getting to newer and newer, some of the newer hardware, such as the newer Oracle SPARC servers, yes, some of them run faster than modern x86, but you also have to think about the workloads. And this is what's really critical here, is a lot of times you're not fully loading these systems. The workloads on these systems have been upgraded from older systems. So one of the things that you look at is, maybe I'm only using 10% of the system. So in that case, you're not going to have a performance impact, but it is something that you do need to think about and address. But the older the legacy system, the less of an impact on performance you're going to have.
All right, thank you. And there's another question. How long does typical migration take?
Usually a typical migration is, as long as you don't have terabytes, it's going to take as long as you can bring over the data, that lift and shift that I talked about earlier. So the actual implementing of the emulator itself is usually pretty quick, and then bringing over the data, and most of it can be done in less than a week.
All right. Another question, how do we find out more about ring fencing?
Well, for the time's sake, I didn't go too much in detail about it, but just please reach out to me directly, or visit our website, www.parsec.com. Send me an email. we can chat about ring fencing in a bit more detail. It's very specific to your environment when it comes to using additional firewall layers within your internal network and how to leverage intrusion detection systems and proxy server techniques and bastion servers, virtualized containers. So in crafting a policy specific to your needs, just really depends. But please reach out and we can have a call and a conversation about that. Yeah.
Okay, I'm not seeing any other questions. I want to thank our presenters for doing a great job today, so thank you guys. And this will conclude the webinar.
Thank you.
Thank you.